So now what we're going to do is practice using these logarithms. The rest of this chapter, for the most part, is about becoming comfortable with these three rules so that you can use them fluently. When you get to algebraic expressions for equations, you'll be able to manipulate them easily with these logarithm rules. So the first one, it says to evaluate this without the calculator. So that's not really a typical test question I would ask because I allow calculators. But the purpose is to get used to these rules and to see how you could use them to evaluate these expressions. So as they're written, I can't do this without a calculator. I don't know what remember this is the common log base 10. I don't know what log base 10 of 5 is, or log base 10 of 20, because I don't know the power of 10 that would give me 5 or 20. But I could apply the first logarithm rule and multiply the inputs. Log base 5 plus log base 10 of 5 plus log base 10 of 2 is the same as log base 10 of 100, 5 times 20. And that's a very common example that we see. We have 10 squared would be 100. The power of 10 that gives me 100 is 2. Okay, part B. Again, I don't know what power of 3 will give me 108 or 4, but we can apply the second rule. And since we have subtraction, we would divide the inputs and get log base 3 of the first one over the second one, 108 over 4, which works out to be 27. Which is exactly 3 to the third. Log base 3 of 27 is 3 because 3 to the third is 27. And then finally, I don't know what power. I know that 4 times 2 is 8, but I don't know the power of 4 that would give me 8 quickly in my head. But I can apply the third rule in reverse here and take the power up. Log base 4 of 8 squared, if we take the 2 up. And then 8 squared is 64, and then 4 to what power is 64? Well, 3. 4 to the third is 64. So here's some numerical examples that I can evaluate without the calculator using exponents if we apply the logarithm rules. Okay. Here's kind of your more common textbook examples. Okay. The next two examples, which each have multiple parts here, are really all about using the laws of logarithms as much as you can until there's nothing else you can do with these expressions. Okay. And they might look really intimidating, like part D there might look really complicated, but I'm going to show you that it's really not, because the exponents of logarithms, or the rules for logarithms, generalize in a pretty nice way. Okay? So if we start with part A, we're going to apply the first rule because we're multiplying. Now, technically, if you wanted to go through step by step, the rule only applies to multiplying two parts. We had an m times n. So what I could do is I could think of this as 2x times yz and apply the first rule and break it apart and get log base 3 of 2x plus log base 3 of yz. But each of those are multiplication, and we could apply rule 1 again and break apart the 2x with a log base 3 of 2 plus log base 3 of x. Y times z is a product. We could break it apart. Okay? So if you look at it, what happens here is I can extend rule 1, and it doesn't matter if I'm multiplying 2 things or 100 things, I can break it apart into that many logs. So there's really, once we see this, no reason to show this middle step. I can break this apart into log base 3 of 2 plus log base 3 of x plus log base 3 of y plus log base 3 of z. Okay. Part B, we have two things being multiplied, each with a power. So we could apply the rule to break apart the multiplication and get log base 5 of x to the third plus log base 5 of y squared. And then when you're expanding logarithms, that means what we'll say here, you want to use the rules of logarithms till there's no more products, powers, roots, fractions inside the logarithms. The last step's always to drop the powers. So you can drop the 3 to the front and the 2 to the front by rule 3. Part C, we can handle radicals or roots by rewriting them as fractional powers, and that's part of what you're expected to do when you expand a logarithm. So log base 10 of 2 times the square root of x plus 1, we can turn that into 2 times x plus 1 to the 1/2. The 1/2 power is the same as the square root. And then you have the 2 times that expression, so you can break it apart into log of 2 plus log of x plus 1 to the 1/2 by the first rule. And then you drop the power to the front. You can drop the 1/2 to the front, so you get log of 2 plus 1/2 log of x plus 1. You cannot break apart log of x plus 1. There's rules for breaking apart multiplication, division, and powers, but there's nothing we can do with the addition or subtraction inside the log. So that one's finished. And then I'll show you on D, really, I can do this in 1 or 2 steps. you're going to wind up with a natural log for the 4, for the x squared, for the y cubed, for the square root of 2, and for the a plus b squared. You'll get a log for each term when you keep applying the rules. And if you don't want to mess up the signs, just remember if it's on the bottom, it's going to wind up with a minus in front of it. So I've shown you here step by step, if you like. Okay. So we've got natural log of this big, huge fraction. The first thing we could do step by step would be to break it apart into subtraction. We'd have natural log of the top minus natural log of the bottom, and I've gone ahead and rewritten my square root as a 1/2 power. And then we could apply the first rule repetitively and break this apart into the natural log of 4 plus natural log of x squared plus natural log of y cubed. And then this is important, you have minus this whole expression, so when you break it apart, if you do this step by step, you need to include some sort of grouping symbols, parentheses or brackets here, and you actually have to run the negative through in the end. But we could break this apart with addition, because we're multiplying, and get natural log of 1/2 plus natural log of a plus b squared. And then you run the negative through, and I've done that and dropped the powers at the same time. So we got a natural log of 4, drop the power, 2 times natural log of x, drop the power, plus 3 times natural log of y, minus, drop the power, 1/2 natural log of 2, and when you distribute, minus, if you drop the power, 2 times natural log of a plus b. Okay? So if you look at this, you can do this in one step if you drop the powers. Each term is going to get its own logarithm, and if it was on the bottom, it will have a minus in front of it because you have to distribute the negative. So if you go through, you're going to get a natural log of 4. When you drop the power, you'll get a 2 times natural log of x, a 3 times natural log of y, and then we got minuses. Once we get to the bottom, a minus natural log of, if you drop the power, 1/2 natural log of 2. And then you get a minus, drop the power, 2 times natural log of a plus b. Okay, we can also go in the reverse direction. Sometimes they call this condensing or contracting a logarithm. It may be useful to take a big string of logarithms and to put them back together as a single log. You can think of this as being exactly the opposite of what we just did in the other direction. So if we reverse what we were doing before, the first step would be to take these coefficients and bring them up as powers. Okay? So 2 times the log of x can be rewritten as log of x squared. You can take the 1/2 up, you get minus log of y to the 1/2, and then take the 3 up by the third rule. Then again, if you want to go step by step, you could combine the minus here and divide the inputs by the second rule. And then you multiply together. And again, when you multiply this fraction times this expression, you can write the x minus 3 to the third on top. You could think of this as being all over 1, and you multiply the numerators and the denominators. Okay? So you can do these step by step, or again, once you take the coefficients up, just put it all together, and anything that's positive goes on top, minus goes on the bottom, is the way the rules work out. Okay? So I'm going to get an x squared on top. I'm going to get a y to the 1/2, or a square root of y on the bottom because there's a minus in front of it. And I get an x minus 3 to the third on top because there's a plus in front. Okay? Again, here's one you can read through step by step, but kind of shortcut it. When you take the power up, you got a square root of x minus 1, and it's positive in the front, so that's on the top. You have a square root of x minus 1 on top. You just have a plus natural log of y, that's positive, so you get the y on top. Then we have a minus, so this term goes to the bottom. You take the power up, you get x plus 3 to the 4th, and that goes on the bottom. Again, we're combining them to a single logarithm, so we have a single natural log of that.